Well, I've been thinking about this for some time now, and the topic of set theory comes up, and it's a little hard to tell exactly how extensively I should teach this, but it's going to come up. I've seen when I was in high school, all the books that I studied from had been in service for decades. My younger brothers were the experimented on group where they tried to bring in some of the things from higher math, including set theory and different bases and modular arithmetic. And when I started teaching school, all of the textbooks began with set theory. But by that time, I had been exposed to higher level math and introduced to set theory. I think I may have even been introduced to it by my high school math teacher in my senior year, because he could see that it was coming on the horizon. But every once in a while you see it. And when I was first teaching, parents came to open house and complained that they couldn't understand the textbook. And I want to explain what happened there. There'd be a problem in the child's book, and the parents, confident that they could help their student with their homework, would see a simple problem like this with the instructions solve, and they'd say, I can do this, like we have talked about already, where an equation is like a balance and you subtract, and they'd tell the kid confidently that the answer was 4. But they would look in the back of the book to the answers, and what they saw was this. And they'd say, I looked in the back of the book expecting the answer to be 4, and I saw all this. Or it might simply say this. And see, the answers were being given in set notation, and the parents had never seen that before, and so they assumed that they had not done the problem right or didn't understand anything anymore, when actually they had done the problem right, because the x that was there was the 4 that was in these statements. And I'd like to read you how you translate this. This says the set of all x's such that, the 2 little colon means such that. In some books it's a vertical line. X is an element of the set with 4 in it. Or they might just have X as an element in the set with 4 in it. And when they got to something like x squared plus 5x plus 6, which they would solve by factoring, they might see that the answer here was x and x. Let's see. And this would give us x is -3 and x is -2. Yeah. And they'd look in the back of the book there and they'd see the set of all x's such that x is an element of the set with -2 and -3 in it. And they'd say, it doesn't make any sense to me, when really all that they didn't understand was this little bit of notation. So let's talk about this set theory. I'm going to delete some of this stuff here, and we'll talk about set theory because it's going to come up. I used it extensively when I was working on my master's degree, and to do higher order proofs, the concept of set theory, which was developed by Cantor at the end of the 19th century, it's essential to solving some of the higher complex math. And it does seem to be a good idea to introduce it to children at a young age. So a set is a collection, can be a collection of anything. And my youngest brother, when he was in school in kindergarten, they started getting him used to set notation by putting pictures inside of the set notation. So these curly braces are used to represent a set. And you could have 2, 3, 5 in it. And that would be the set that contains 2, 3, and 5. You can have a set with nothing in it, and you could use the symbol, this empty set could sometimes stand for the set with nothing in it. And so when they solved a problem, you might give the answer as a set. And when you have some other symbols that come up, then if you wanted to say that some x belonged to that set, like when I said x was equal to -2 and -3 in that last problem we did, and we write down x, and this little e stands for is an element of this set. So that was when we solved it. We found out that x was an element of this set. It's kind of easy to understand. This is for the empty set. There's also the use of a curvy R, or I can show you the printed one that's a curvy R like this to stand for the set of all real numbers. Now, sets can be described by rule, saying the set of even numbers between 1 and 5. That would be by rule, and even numbers between 1 and 5 would be 2, 3, no, not 3, 2 and 4. Even numbers between 1 and 5 are 2 and 4. This is by rule, giving some sort of explanation for it. And roster is by actually listing them. Rule and roster. You'll see in some of the books they'll give you a rule and then see if you can't figure out the roster solution for it. I want to talk also about subsets, like if we had this set with 2, 3, 5, we could find out what are the subsets of this, which is kind of a simple concept as well. This is a set, like let's say this is set A. We could list all the subsets of A. Well, you could have nothing, empty set. You could have a set with 2 in it. You could have a set with 3 in it. You could have a set with 5 in it. You could have a set with 2 and 3. You could have a set with 2 and 5. And you could have a set with 3 and 5. Or you could have a set with 2, 3, and 5. I believe that's right. These are all the subsets that have one element. These that have 2 elements. And these that have 3, this one that has 3 elements. And the set 3, 2 is identical to that one, so the order doesn't matter. It's the same collection, so you wouldn't have to write it down this way as well. So subsets, and subset symbol is usually written like if you wanted to say that the empty set was a subset of 2, 3, and 5. It's this like curvy, it's a little bit like an inequality, but it's not, it's curvy. That means this is subset of. Got that? Now, then there's one other thing. We want to sometimes say intersection and union. I'm thinking that maybe I need to write a program to check you on whether you understand these things or not. I haven't written a program on this, but maybe it'll come to fruition. We might want to be able to tell, like, let's make a set A, and make it be a set 2, 3, 4, and B be the set 3, 4, 5. Then we could say, what's A union B? Union would mean add everybody together. A union B. You wouldn't put this, you don't write this down, this arrow. This stands for union. So if you said, everybody in here join the club, everybody in here join the club, well, you'd have a 2 would belong, 3 would belong, 4 would belong, and 5 would belong. You wouldn't need to put the 4 down twice or the 3 down twice. This is the union of those two sets. Then if you wanted the intersection of those two sets, you do this upside down U. This is union. And then this is intersection. And this would be, we'd be asking, where do these two things intersect? Well, they don't have a 2 in common, but they have a 3 in common, and they have a 4 in common. So the intersection is that, union and intersection. If you get those concepts, then that would be good. You never know when you're going to bump into set theory. It seems like every other set of books has it in it, and sometimes it's presumed that you have some background in it. There was that time when everybody was studying set theory in kindergarten, and they could throw in that notation, and students remembered it from kindergarten, but then they took it out of kindergarten, and then we had a whole class of students that didn't know anything about set theory and were confused when it's used. It is used in higher mathematics, and so you're going to have to learn it sometime if you're going to go far with math. So you might as well get used to it. It's not that hard.